Okay, Year 12, today we're going to be looking at exercise 3G, which is on recurrence relations. So to start with, the form of like the nth term of a sequence you already looked at is called a position to term sequence, because each term in the sequence is derived from the position. So when you're looking for the second term, you substitute in 2, and the third term you substitute in 3, and so on. But a term might also be defined based on its previous terms in the sequence. So if u of n refers to the current term, un plus 1 refers to the next term. Okay, so this example, like if you put this into words, it means the next term, so the next term is 2 lots of the previous term plus 4. But then you also need, for a recurrence relation, the first term. The recurrence relation alone doesn't give you enough to know where the sequence starts from, so you need to be given u of 1, which in this case is 3. And so this is known either as a term-to-term sequence or a recurrence relation, and it's called that because the sequence recursively refers to itself. So, for example, we've got this sequence here where the first term is 1 and it's defined by this recurrence relation a, the previous term, plus 5, and the first term is 1. Write down an expression for x2 is the second term of the sequence in terms of a. So all we are going to do here, x of 2 is going to be a lots of x1 plus 5, and in this case x1 is 1, so it's just a plus 5. For part B, show that x3 is a squared plus 5a plus 5. So this is going to be a lots of the previous term plus 5, and then all we need to do is expand and simplify to what we've got. And finally, for part B, given that x cubed is 41, find the possible values of a. So a squared plus 5a plus 5 equals 41. So then a squared plus 5a minus 36 equals 0. Factorising that, a plus 9, a minus 4 equals 0. So then our two different values for a are a is negative 9 or a equals 4. And that's it. Okay, so with recurrence relation questions, the sequence that you generate is nearly always not arithmetic or geometric. And that means that the previous formulas you've learned aren't going to apply. And we'll look here in this question at why that ends up being relevant. So to start with, k is a constant. This is our recurrence relation here. So the recurrence relation in words basically means the previous term squared minus k lots of the previous term. So to find x2, it would be x1 squared minus k lots of x1. And in this case, x1 is 1, so it's just 1, take minus 1k, so 1 minus k. Then for part B, we need to find x3, which is going to be 1 minus k squared minus k lots of 1 minus k. We would then expand this, so 1 minus 2k plus k squared minus k plus k squared, and then this simplifies to 1 minus 3k plus 2k squared. Part C also really similar, so calculate the value of k. So 1 minus 3k plus 2k squared is going to be equal to 1. We can then rearrange it to make it equal to 0. So 2k squared minus 3k equals 0. So then we get k, 2k minus 3, 0. So either k is 0 or k is 3 over 2. And because k is a constant, it's going to make sense that k is going to be 3 over 2 or 1.5. And then finally, for part D, and this is where it gets a little bit harder, find the value of the first 100 terms of the sequence. Okay, so find the value of the first 100 terms of the sequence. We can't just use a formula here. We're going to need to do a little bit of thinking. So let's begin by thinking about what the first term of the sequence is. The first term is 1, we're told that. Then the second term, if you calculate that by up here, we know it's 1 minus k, and we know that k is 1.5, so the second term is minus 0.5 or minus a half. Now let's work out the third term. So to work out the third term, you can just substitute k equals 1.5 into this, which is 1. And if you calculated the fourth term using the recurrence relation, you get minus 0.5. And so what you will see is that this sequence is going to repeat. So effectively, you've got 1 plus, oh, let me write that out again. You've got 1 plus minus 0.5. And then how many of those pairs will you have between 1 and 100? You'd have 50 of those pairs. So it's 1 plus minus a half, or 1 minus a half, times 50, which is therefore 0.5 times 50, which is 25. So the only thing you really need to watch out for with these recurrence relations is this type of question when you're summing. But other than that, this should be reasonably straightforward. With that in mind, have a go at exercise 3G now.